Hello, everyone. So today we'll be going over introduction to backend development. I'm Nabil,
My name is Kaushik.
and throughout the presentation, feel free to stop us if you have any questions. Just an overview of what we'll be covering. We'll be going over protocols, databases, and frameworks, as well as hosting. So trying to give you like the bigger picture of what backend development is all about.
The first topic we'll be covering is protocols. As you all know, one of the most common protocols we use in our day-to-day lives is HTTP. This is pretty much the standard for all websites nowadays. So this is a protocol that's used for fetching resources, and the main communication method is through clients and servers. Us being the clients and servers being hosted by people like Amazon or Google or so forth. So normally clients are the ones that make the request outwards to servers, and the servers return a response. So the HTTP relies on a few common methods that are pretty much integrated for everything. The get method is used to retrieve a specified resource. The post method is used to submit an entity, usually outwards, and the delete method is used to delete specified resource. More HTTP methods can be found in the link right there. So normally, when you're using HTTP, the developers implemented status codes that you can see whenever you make a request. So the most common one is 200. This indicates that the request went through and everything went smoothly with nothing lost or destroyed in the process. A 403 error means that you don't have access to the website. Usually this is a client-side error. If you don't have access to a certain website or the owner has made it private or something, this will happen. A 404 error means that it's not found. This usually occurs when either the website has been taken down or just no longer exists. And error code 500 means that it's an internal server error. This means that this usually is server side. This means that either like a database is down or the website's down. More status codes can be found in that link below. This is an example of an HTTP request. So as you can see, the first line shows the URL that you are requesting from. In this case, it's a Discord API, and it's going to be reading messages. So normally, you can see that we are using a GET request. So this is essentially fetching all the messages from that certain Discord channel. The status code that we received is 200. So that means that everything went well and everything was pulled properly. The next two lines refer to the remote address. So this is basically where we were pulling from. And then the refer policy is just policy of how it's pulling. So this is another example of HTTP. So this is specifically the data we are pulling. So depending on what website you're using, the data you pull varies. So for example, so here in this case, we're pulling ID type, content channel ID, and so on. It doesn't necessarily have to be the same for other websites. For example, it can be like phones, contacts, whatever data you're storing on that website. It's usually stored in this kind of JSON format, so it's easy to read. Yeah.
And now we'll be talking about the WebSockets protocol. So the WebSocket protocol is a two-way communication session between the client and the server, and it doesn't rely on opening multiple HTTP connections. And the use cases of it are chats and like live delivery. And so we're gonna kind of talk about the difference between making a GET request and like doing and using the HTTP. And using the WebSocket protocol. So on the left, let's say that we're building a chat application, right? And so users are constantly sending messages, right? And so one approach that someone might have is that they might make a GET request, or they might like constantly poll using a GET request every like 1 second to get the new chat messages. So you see here, the client makes a request, and then the server responds, and then the client makes a request for more messages, and then the server responds, and the client makes another request, and then the server responds. So what the WebSocket lets you do is you kind of like come to an agreement with the web server. You do your little handshake, and in this agreement, the server promises to always tell you what's going to happen. Like it's always going to tell you when there's a new message without you asking. So you can kind of see on the left side, you always have to ask the server if there's a new message being sent in the chat. And then on the left with the WebSocket protocol, you don't have to ask. The web server automatically knows that, hey, we did this handshake. I'm going to always tell you, uh, you know, that like exactly when someone sends a message and what message they send exactly. And so here's a WebSocket example from Twitch. So I've just picked a random streamer, I guess in this case ASU. And so in the network tools in Chrome and other browsers, you can see all the server requests that are happening. So it's a really cool tool. But looking exactly at the WebSocket example, you can see that the down arrows, the red down arrows are when we're downloading or we're getting information from the server, and the blue up arrow is when we're sending information. So the red down arrow is right. I didn't have to ask Twitch for this data. Like I already, through the WebSocket protocol, I already came to agreement with the Twitch servers that, hey, anytime a user sends a message, just download it, right? Just like, give to me. And you can see here when it's blue and it's like, I'm uploading information, that's actually me telling ASU, hey. And you can actually see right below that, as soon as I send ASU the message, it goes to the Twitch servers, and then the Twitch actually makes me download kind of like my own message. So that's kind of useful. You can kind of use that to like actually verify if your message went through, when you're developing stuff, but yeah.
The next topic we'll be talking about is databases. So a database is an organized collection of data that can be stored and accessed electronically. So one of the most common database languages is SQL. So SQL stands for Structured Query Language. So it's a language that interacts with databases through relational means. Examples of SQL frameworks are MySQL and Postgres. On the other hand, there's also No-SQL. So this stores data in means other than tabular relations. And that although it's not in an exact tabular format, it's still used with relational databases. Okay, so this is the main breakdown between SQL and NoSQL. So in SQL, the database's data is broken down into various logical tables to avoid data redundancy and data duplication. So for example, in this scenario, SQL databases are faster than NoSQL counterparts for their joins, queries, updates, etc. So what a join is, when you SQL join this means you're combining two tables together. So suppose you have a table that stores phone contacts and you have a table that stores addresses. So you can basically combine these together in one table that stores both of them together. Queries are essentially the commands you run. So like, example in terminal, like you can run normal commands like ls and stuff that shows you your data. Similarly, queries are the commands you run to modify or access like tables inside SQL. An example is like if you want to select like your phone contacts from your database, you can say like select phone contacts from and then your table name. Updates, similarly, this is just to update data inside your MySQL database. You can just do this using update SQL table from so on and so forth. So NoSQL, on the other hand, are designed for unstructured data, and this is usually document-oriented, column-oriented, and graph-based. In this case, the data entity is stored together and not partitioned. So performing read or write operations on a single data entity is faster than NoSQL databases compared to SQL. So for NoSQL, all your data is stored in usually a JSON format. And usually it's separated. Sometimes it can be structured, but it's usually separated. So suppose you have like phone contacts and addresses, like I mentioned before. So in this case, it will store phone contacts in one JSON document while your addresses are stored in a separate JSON document. So this way it doesn't cause clutter, and also it stores them separately. So this is a picture that shows the main difference between SQL and NoSQL. So on the left, you can see everything's kind of like intricately connected. So in this case, all the tables are within one database, and they're pretty much like accessible from like one place altogether. On the other hand, NoSQL is like a much more like dissected. As you can see under the document portion, all the data is separated in different documents, and they're accessed using key values. So essentially, one document can be like have the key like phone, other address, like other house, so on and so forth, and that's how you access documents. So this is going more in depth regarding SQL. So as mentioned before, SQL is used in multiple different relational database management systems like MySQL and Postgres. So all of these management systems have a slightly tuned version of SQL to fit their own database systems, but overall they follow the same standards. So most of the time they're always gonna have a select method, an update method, delete method, all the core things that SQL has as a structured query language, they're all gonna have. So MySQL was actually one of the first open source databases available on the market. It was released back in the 1990s. So this is most commonly used in client-server relations or embedded systems. So MySQL is actually very common for even like small developers, and it's really easy to set up on your own computer. It also has the upside of having many common languages that can interact with it, such as Java, SQL, or Java, C++, Python, so on and so forth. All you have to do is import that MySQL framework, and then you can use it. Postgres is it's similar to MySQL, but it's much more powerful open source relational database system. It's also been out for about 30 years. So Postgres is much more advanced, and I wouldn't say it's like a little less user friendly, but it has a much more specialization. So some of these, as you can see, is data types, data integrity, concurrency performance, extensibility, text search, and security. One example of a company that uses this is Salesforce. So they do a lot of cloud computing, and overall, like they have a very high sense of security, and this is why they use Postgres. So this is an example of a MySQL table. So as you can see on the left is a column. So this is basically, you can think of these as like your variables. So as you can see, like the first three are ID, username, first name. So normally ID is gonna be always set like by default to your table. This is to distinguish between different tables and different values you're storing. The second column, as you can see, is your type. So your type is going to represent what type of data you're storing inside your table. So these don't necessarily have to be the same within table. Like one table can store an int, a string, date, time, so on and so forth. You can also set a default value if you want for certain fields. For example, if you want to set username default to John Doe, if you don't enter anything, you can do that in that column. So nullable, what this means is you can either decide if the value is allowed to be null or it's not to be null. Null essentially means empty or the object does not exist. So for example, if we want to ensure like in a login system, if the user has a first name, last name, so then we would set this to null. So this pretty much means when you create your user, you must have a first name, last name, or you're not allowed to create it. Character set, we can kind of ignore, is just something that's it's more low level thing regarding MySQL, and same with collation. So privileges is what the current user who is logged into MySQL can do. So in this case, the user we're logged into can select, insert, update references. So this is usually like admin privileges overall. That means you can update the data and change it however you want. The next thing we're going to be covering is NoSQL.
So for NoSQL stores data in means other than tabular relations using relational databases. So what this means is that it's basically kind of like document based, right? With SQL, you have like all these like tables and they're all kind of interconnected to each other through these different relationships. Usually you could do it through like IDs, right? Like you have an ID for like you have a user ID in the, I don't know, communities table, to kind of connect, right, to this other table. So NoSQL is more kind of like document based and things are usually not so connected. Um, and so NoSQL databases, they actually scale horizontally. So they can handle increased traffic simply by just adding more servers to the database. And they can become larger and more powerful, and they're the preferred choice for large or constantly evolving data sets. And so the way that they're able to scale horizontally is through sharding. And it's a method for distributing a single data set across multiple databases, which can then be stored on multiple machines. And this allows for larger data sets to be split into smaller chunks and stored in multiple data nodes, increasing the total storage capacity of the system. So you can see here, instead of having kind of like a centralized database, we're kind of, taking off pieces of it and kind of distributing it to different places. And so, yeah, this is essentially what lets it scale horizontally. And and when you scale horizontally, it's nearly limitless how much you're able to scale when it comes to handling big data and intense workloads. Uh, the opposite of horizontally scaling would be vertically scaling. So this refers to increasing the power of a single machine or a single server through buying, a more powerful CPU, adding more RAM, upgrading the type of like storage, or just upgrading the storage capacity. And so one of the cons of sharding is that there's a lot of overhead that goes into it. So it's not, there's always pros and cons, right? At the end of the day, it just might be easier for you to just buy a new CPU or just put in more RAM into your server and just call it a day then. Um, but you kind of just got to see like what you're working with, right? There's always pros and cons with these kind of things. And so MongoDB is a NoSQL database. And so it's a source available cross-platform document-oriented database program. And what source available means is that it's not like open source. Um, and so you're able to like see kind of like what code makes up MongoDB, but it's not necessarily open source in the sense where like anyone can like freely contribute code into it. And I was looking a little bit into this, and it looks like it's not like 100% that you can't contribute, but like I think it's just a lot more restricted than like open source, if that makes sense. And MongoDB is a NoSQL database that uses JSON like documents with optional schemas. So so this is an example of a MongoDB document, or kind of like the schema, right? So here we can have a title car, but then we're going to require the fields um, ID, year, the make, and the model, and the miles, right? But this is something that you don't have to actually set, right? This is kind of like what Kaushik was going over earlier with the user table for MySQL, right? How you had in each row you had a defined a data type. This is kind of MongoDB's version of that, but overall, MongoDB is actually a lot more free for all. You don't have to define a schema at the end of the day. You can literally just put whatever in your document, and uh, it'll be fine. Like except MySQL will scream at you if you try to do that. But yeah.
So another NoSQL database that is pretty common is Firebase. So Firebase is actually Google's version of a mobile development platform. So this is really common when building phone applications for iOS or Android. Like Nabil was saying, for like the schema for MongoDB, it's pretty similar. So you can split your data up into documents, and then you can it's pretty easy to pull the documents. You just sort of set up a couple APKs, and then you can pull it. So the one perk of Firebase is everything is hosted in the cloud. So the only downside is Google charges you depending on your document usage. So this is usually to scale for like bigger companies, but I think they start charging about 50,000 document reads. This sounds like a lot, but it's actually not a big number. Like think about if you had like 100 people entering what they ate in a day, for example. So on average, like one person enters 3 times a day. And on top of that, a document read consists of either editing, writing, or seeing it itself. So up like I'd say on average, a person would use like up to 10 document reads per day. So yeah, this scales like really fast. So that's the one downside of using this. So this is the implementation path for Firebase if you want to implement it into one of your applications. So the first thing you'll want to do is implement the SDKs. So there's a thing called cacao These are pretty much like kind of like a software you can install onto your system. They're like mini scripts. This essentially installs the Firebase SDK into your application for you to use. So after that, after you've set up all Firebase and everything, so essentially you can import Firebase into your application, just like import MySQL, for example. And then after that, you can essentially read or write JSON data just using code. You can just write a couple lines and then you'll be able to interact with the server. So one cool thing about Firebase is when you run it on your application, it'll always have a listener. You can set to always have a listener. So essentially what happens is say you're making like a calendar application in which you can enter events. So suppose like Nabil enters like let's say going to the gym at like 7 p.m. and say he changes it to like going out to eat at 7 p.m. So the listener on my phone will actually be able to listen to that and it'll update it on my device instantly. However, suppose if I didn't have internet, Google has actually thought of a way to counteract this. So normally you would think if you don't have internet, you would not be able to pull from Firebase. But one way they circumvented this is they enabled offline persistence. Essentially what this means is, so even if Nabil updates it to going out to eat, my version will still be going to the gym. So essentially it'll cache the old data on my phone in its local storage. And whenever I'll use the application without internet, it will use the most recently cached version of the data. Additionally, one more perk of Firebase is has lots of authentication methods. For example, it has Google authentication, Apple authentication, phone authentication. There are many ways for you to like log in and secure your data. Next, we'll be talking about frameworks. So one common framework that's used is ExpressJS. ExpressJS is an unopinionated web framework for Node.js. Node.js, as some of you may know, is a JavaScript runtime environment, otherwise known as JRE. More can be found about this at expressjs.com. So this is an example of an ExpressJS code. So as you can see the first couple lines are just initializing ExpressJS, and then we decided to use port 3000 for this certain example. So line 5, this essentially is setting up a listener for whenever you make a request. So in this case, we're going to be sending hello world. And then on line 9, we're essentially having a listener that listens to the port we initially had, which is port 3000. And we're essentially outputting what the port received from the request. So in this case, we're just outputting hello world. Additionally, Tomcat is a free open source implementation of Java Servlet, expression language, and WebSocket technologies. So this is also built off of GRE, as mentioned before, a Java runtime environment. This is described as a pure Java HTTP web server environment, and more can be found at that link below. So essentially, after you set up Tomcat, this is kind of the screen you will get to. So Tomcat, as some of you know, like the localhost is a really common thing when testing backend servers. So essentially, localhost is suppose like Google.com. So that's like their main backend server that everyone in the public can use. But like most of the time, when they're using development kits or development versions, they'll run on local machines. This case, or in this case, like even if you have a bug or something, you'll be able to like test it on your own machine before sending it out to the main development. So through Tomcat, you can also manage the application or the server you're running, and you can also change your hosts. So Flask is similarly a micro web framework written in Python. So the micro essentially means that Flask likes to keep its core simple, but extensible at the same time. So this is an example of Flask written in Python. So the first line, we're just implementing Flask, and then we're just letting the application know that's running under Flask. So then we're essentially just writing a hello world function, and then we are returning that.
And so now we'll be going over hosting. And so there's a lot of hosting options. We just picked 2 for today, but there's tons of them. But one of the most popular ones, and one of the reasons why Zyblix goes out a lot, maybe not a lot, but it goes out, is AWS. So AWS is a cloud platform with a variety of services. They have cloud servers, load balancers, databases. They even have some blockchain stuff. They have some quantum computing stuff in there. It's crazy. But we're going to go over just 2 of the services, just highlight 2 of those. One of those is the Amazon EC2 compute platform. And for any of you guys that have taken CS 100, I don't know if you remember this, or but in CS 100, in the terminal, you'll like SSH into like the like Hammer servers or whatever it was called when you took that class, and you just kind of like work on that computer remotely. And that's kind of what you're doing with this Amazon EC2 compute platform. So essentially, Amazon lets you buy a computer, or at least rent out a computer, and there's like a range of computers that you can rent out. And they'll give you an IP address that you can SSH into at that with the computer that you're renting out. And then from there, you can host, I guess your game servers or your websites or whatever you want. It behaves like a regular like Linux computer. And it's kind of like yours to play around with until you run out of rent money. And another service is the Amazon S3 object storage. And so this is like a file server. You can think about it like that. Like if you look at the infographic, right? We have analytics data, log files, application data, videos, pictures, backup, and just an archives of information or whatever. But basically, they're just files. At the end of the day, they're just objects or just files. It's just data. And object storage just lets you store these objects onto the like Amazon servers, and you can actually organize this data into different buckets. And within these buckets, you can specify, what regions or who has access to each bucket. And one thing you might use this for is, if you're making an app and you need to store user profile pictures, right? Instead of trying to store all the user profile pictures inside the compute a platform that we talked about previously, right? Because those profile pictures can like scale like immensely, right? So what you can do is you can just like use another one of it. We can use this Amazon service to store those user profile pictures, and then you can just use those, and then you can just use a compute platform to handle, what happens when a user uploads a picture. Just handling those events, but at the end of the day, just sending all those pictures and images and files to the Amazon S3 object storage. And so essentially what I'm just trying to stress right now is that it's separate from the compute platform. They're kind of like 2 different services, but you can make them work together. And another one of them is DigitalOcean. It's like AWS kind of, but it has a lot less stuff. They have a cute little name for their little cloud servers. They call them droplets. They also have object storage and load balancers. I think you actually get $100 if you, or like $100 credit if you go to a hackathon and they're like, think like sponsoring it. But basically, when you create a droplet, right, you're creating like the computer that you want to rent out. So you have a range of Linux distributions to choose from. Choose Ubuntu, FreeBSD, Fedora, Debian, CentOS, and Rocky Linux. And actually, I didn't even notice that before. You can actually pick what version of it you want. Yeah. And then over here, you can actually describe the hardware that you'd like to, use. They have, I'm not sure what the difference is between regular and premium Intel. Probably just faster, I guess. I'm not sure. But then they also have AMD CPUs, and you can just, kind of choose how much RAM do you want, how much storage do you want your computer to have, and yeah. And yeah, here are these options, right? So like Spaces is, I'm assuming, is similar to the Amazon bucket service where you can store those images. Yeah, you can also have databases, and you can also have load balancers as well. Uh,
So
yeah,
you
go
want to
ahead.
answer it?
No, 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 go
Okay.
ahead, go ahead.
Okay. So Khalil asked, do you think it's important to know front end things when working on back end? So I guess like one way to answer this is so example like take an application. Of course, if you like solo development, I mean, I guess you have to look at both spectrums, but front end is more like UI based. You're kind of looking at visuals of what's in front of you. On the other hand, back end is kind of like handling all the data. So you kind of want to see like, oh, are my like profiles or contacts being transferred from the server to my application, so on and so forth. I think you should have a general knowledge of what's happening in the front end, because as a backend developer, you want to be able to know how the front end wants its data, so it's easy to use essentially. Like for example, like if front end wants to split up, let's say your profiles into like separate groups, for example, you don't want to have them like all clustered into one big group. If that makes sense.
I also want to add that I guess I've never worked at a front end role, but coming from someone who switches between back end and front end a lot, um, I learned a lot of back end from working on the front end, because kind of I guess you're kind of like you're kind of saying how your data comes out, right? Like when you're on the front end, because on the front end you're making calls to stuff that's in the back end, right? So uh, kind of like how Kaushik was saying, right? So you need to know what's going on in the front end because you know when the front end makes a call to a back end, the front end needs to have access to certain things. So uh, so like for example, right, if you're a front end developer and you want to make a request for user profile data, uh, you have to at least know how to actually make those requests to get the data. So you have to know that you need to have like a cookie in your call, or you need to know that you have to store the cookies. Um, or like, or so, okay, I should say, so cookies can also be used for authentication. I should have said that earlier. So a backend developer can make it so that whenever a user registers, that one of the responses will be like a session ID. And if what a front end developer can do is they can kind of take that session ID and store it in as a cookie, and then that front end developer will now be kind of responsible for making sure that they feed that cookie into all the like HTTP requests that they make when working on the front end. So you don't have to know like how the backend stuff works exactly, but you should at least know how the transaction works. You should at least know how to request information, but you don't have to know how that request happens exactly. So I'm kind of going on a tangent here, but just to summarize it, I feel like you should just know how to request things and why you're putting certain things in a request, and then you should know how to handle responses. So like And I think one important thing is to know status codes, right? Because when the backend responds with a 404 or a 500, right, you as a front end developer has to say, okay, when I get a 404 or a 500, what do I render? How do I make the UI respond to this kind of thing? So, at least knowing basically just the exchange of just a transaction, the request and the response is what you need to know, but not how to actually make it. Sorry for a long answer, but yeah.
So Adil asked for servers supposed to handle unauthorized people making GET post requests. So normally I think, at least with a couple of servers that I've worked with, you usually have some sort of like access. If you're able to make like GET and post requests, like that means like the system you're on or like whatever you log into has like a high level authentication. So usually like companies will have like certain levels of authentication that allows you to make those requests. For example, one of the companies I've worked at before, we had to clone an SQL database, and then we had to essentially like SSH and provide certain credentials to be even able to access it. So servers, I guess, don't really filter GET and post requests, if that answers your question. But in general, there will be levels of authentication necessary to be able to get to that level to make GET and post requests.
And then just to add some more, so the way I thought about this too a lot, and so if you had the front end managing who makes a request or not, at the end of the day, you're on the front end, right? You can change that front end code to do whatever you want, right? You can always change the JavaScript and you can make it like, it's like, so if a front end developer wrote some JavaScript to prevent you from doing something, well, I think you could technically just remove that JavaScript and do whatever you want. So you don't really, like you don't make it the front the front end. You don't make it responsible for filtering stuff out. You kind of have the back end, like how Kaushik was saying, right? How there has to be like some kind of credential sent in, right? So unless the backend gets that credential, that password, that cookie, that token, whatever it is, unless it gets it, it's not going to give you uh, any information that's useful for you to work with, if that makes sense. And yeah, so that's it for today's workshop. Thank you all for coming over here, and I guess we'll stay after if anyone has any questions. But yeah, thank you.
Thank you guys so much.
Woo, let's go!